Hello, welcome to another video from Berkshire Guitar Amplifier Repairs. I'm Stuart Smith, and up on the bench today we have a Marshall EL34 5050 power amplifier. This is basically a stereo amplifier with two channels, each producing 50 watts. The customer has brought it in. Apparently there's nothing ostensibly wrong with it, it's not faulty, but he's got another one and he feels that this one is lacking in power or lacking in a bit of punch or something. It's always very difficult when customers talk to me tonally about an amplifier being a little bit flabby or a bit weak or a bit, I don't know, up in the bass or down in the treble or something, because these are very subjective things. I always prefer to have a hard fault on an amplifier to fix. But anyway, I said I'd have a look at it for him, and I think it might be of interest to you, because what I'm going to do is get a load resistor on the outputs and measure the power output of each side, and if it produces 50 watts, that's job done. And then I'll also sweep through the frequencies just to make sure that it's relatively flat across the frequency spectrum, and if that's okay, it's job done and I can sign the amplifier off as working properly. So I think it might be interesting for you to see how I measure the power output of an amplifier. So before we do any of that, we've got to get this beast out of its flight case, and I'll probably also get the covers off it so that we're ready to work on it and have a look inside. And you never know, when we look inside we might see something we don't like. But anyway, let's get it out of its case and we can take it from there. Okay, here we are inside. Bit of a mission to get inside this actually. Lots of screws and trying to work out which ones you take out to get the top off. But anyway, I've got the top and the bottom off. I'll show you the bottom in a moment. So here we are on the top side, and of course the first thing I notice, as indeed will you, is these transformers and the state of them and this strange kind of growth, aluminium metallic growth on them. I'm not quite sure, to be honest with you, what has caused this. It's kind of powdery. If you just touch it, it all just crumbles into dust. It's obviously been in some sort of environment here which has caused, I don't know, almost like a crystalline growth to grow on top of there. They're also fairly rusty, look. The laminations, that one's not too bad here. That one. This has been stored somewhere, a garage or something, which is not very conducive. What else do I notice? Other than that, it's kind of fairly clean inside. I notice the valves are quite old. I'm guessing these might be originals, these. I might see if I can get the guy to put a new set of Marshalls in. Okay, they're Svetlana EL34s, probably the originals. I'll get those on the tester in a moment and see if they're all working and if they're a matched pair. What have we got on the preamp side? Again, I can't immediately see a make on that. Bog standard generic ECC81 from China, probably. Not even got a brand name on it. What about this one? Marshall ECC83. I think these are the original valves, and it'll be the same here, of course. It's just a stereo amplifier. You can see, look, two EL34s for one side, two EL34s for the other, duplicate HT caps, duplicate transformers. So they've just duplicated everything either side. So I might try and go for a full Revalve, but anyway, we'll test these valves maybe. So I think I might do that before I do anything else. But before I test the valves, I'll flip it upside down so that you can see what the underside is like. Here we are on the underside, and it's got this sheet of perspex covering everything, obviously for installation purposes. I've had this sort of thing before, and it's all a bit weird where it's kind of tucked under each of the four sides equally, which kind of makes you wonder how you get the thing in and out. I have done this before, got these in and out, but it's not easy. You end up feeling you're going to crack the plastic getting it in. But anyway, I don't need to take this out if I don't have to. So there you go, there's a shot of the entire amp. Printed circuit board, as you can see, all looks very neat and tidy in there, so nothing particularly to worry about. I see they have a mains transformer for each side, which is interesting, so they didn't have one big heavy mains transformer. Maybe they wanted the thing to be like a mono block, you know, two mono blocks side by side, and they didn't want it to be asymmetric. And of course you would have ended up with a double-sized power transformer anyway, so a huge beast of a thing. So maybe that was an issue too. So this whole thing is just literally a mirror image, left and right. Right, so nothing, I don't think, to worry ourselves here on the underside. I'm going to concentrate on the top side, and the very first thing I'm going to do is to test out those valves on my homemade power valve tester. So join me there. Okay, I've shown this before on camera, but in case you haven't seen it, homebrew valve tester. I picked this up off a skip, and it's got bias voltage and DC up to 350 volts. So it was obviously a valve testing a piece of equipment, and it's even got the heater supply, which I've just brought through into some sockets here on here, and made a note of some voltages. And this just allows me, these meters allow me to measure the bias voltage, usually on pin 5, and measure the bias current through a 1 ohm resistor here, and to measure the plate voltage on a meter. So I've got 3 meters. So let's pull the first valve. In fact, I pulled all 4 whilst I was there. So let's have a go. On EL34s I normally put a 330 volt plate and a minus 28 volt bias. So let's do that. We can turn the voltage down to 330 on here. You may not be able to read the meters, that's 330. And we'll come down to minus 28 on the bias voltage. Then I interactively adjust these to keep them at the levels I want. So 330 volt plate and minus 28 volts on here. And that's settled down into actually quite a high current. Let me just double check that. EL34, 330 volts and minus 28. That's quite a high current, that. That's going up to 48 milliamps. 48.6, so I'm going to call that 49. So our first valve is 49, I'll just write that down. Put that there, and do our second one. It doesn't matter how old a valve is in terms of years, it's the number of hours it's got on the clock. A bit like car tyres really. So these could be 50 years old, but if they were brand new out of the box they would be perfect. Or you could have a valve that's a year old but it's been absolutely hammered. So again, these are quite high current for an EL34 at this bias voltage. This is 55 and rising. 55.3, 55.4, 55, and call that 56. So again, that's not very well matched to our first one, which was 49. So we don't have a matched quad here. I think I'll call that 57. Make a note of that. So we've got a 49, a 56 and a 57 milliamps at this condition. And we'll just check the final one. I think we'll go for 54 on that. Okay, then on the mile out we've got a 49, a 56, a 57 and a 54. I'll just recheck that 49 because those 3 I would accept as being matched. Let's just do a double check on the one that's giving a lower reading. Yeah, so that is 49. Right, so the power valves are working and are reasonably matched. I'm now going to just check the preamp valves on my orange valve tester. Again, I've showed this valve tester before. We select our valve, in which case we will do the ECC81 first, so you just press this until this goes along to ECC81. pop the valve in and press check, and this will start cycling through, and eventually fewer and fewer LEDs will be lit until such time as it gets to the end of the test, in which case only that one will be that one will be lit, and it will give us a result. Don't forget, in a preamp valve you've got two valves in one, you've got two halves, identical triodes in one envelope, two valves, and this will give us the gain of each side. So for example, if the final light is 8 and a 10, that will mean that the sides are slightly mismatched. If just one light is on, let's say a 10, it means that both sides are the same. So we'll see what happens here. It's going through its cycle now. Won't be too long before that's done. I don't think I'll make you watch all four valves, but I think we'll do the ECC83 after this one, and then we'll have done one half, and I can do the other half, the other two valves, and let you know the results. Here we go, coming to the end of the test. Any minute now, some lights will light up here. There we go, and we've got a 7 and a 10. So again, that's quite a big mismatch. It'll work, of course, and by the way, it's come up good on a green light. So the valve's basically okay, but the gain of both sides is quite different. There are two different gains in that envelope. So we'll just pop that back so that we remember where it goes. And we'll take out our ECC83, Marshall ECC83, and we're going to have to select now a different valve. How do we do that? There we go. We select now the ECC83, that light's lit. Now we can pop this valve in, press test, and it starts its cycle. So we'll see what this ECC83 is doing. I would recommend, I think, to this customer a full revalve, but of course it's all money, and if the valves are basically working, which they are, and depending on what he's doing with the amplifier, it might make more economic sense to just leave well enough alone. And I can test the gain and the frequency response, and if it's good, if we've got 50 watts each side and the frequency response is nice and flat, hey, what's not to like? It's just the same as cars. When you start taking a car engine apart, do you change the partly worn belt, or should you leave it for another few thousand miles? And these are just economic decisions on the part of the customer, really, rather than technical decisions. This is nearly coming to the end. Should get two numbers, or one if we're lucky. Oh, see, this is more closely matched. So basically, one side is a 6 and one side is a 7, and it's come up good. So I'm happy with that valve. That's okay. I can go back in, and I'll just now do the other two, and I'll report back to you on the results. Okay, this is the second ECC83, the one in the left hand channel, and that's come up good, and again 6 and 7 fairly closely matched halves, so I'm happy with that. I'll now do the final ECC81. Just coming to the end of its test now, and again it's come up good, and a 7 and an 8 on that ECC81. So that one's fairly well balanced, matched I should say, sorry, compared to the other ECC81 we did. So all in all, the valves are sort of okay. There aren't any obvious faults or anything. So the next thing to do, I think, is to get all the valves back in. I think I will check the bias on the left hand side of the amplifier and the right hand side of the amplifier to see what's going on there, and rejoin me when I've got that all connected up. Okay, here we go. I've taken the inside pair of the valves I tested because they were fairly closely matched, I think 56 and 57 milliamps from memory. I'm just going to put one pair of valves in I want to see what's going on here with the bias current in this amp. So I've got 2 meters on the go here. Eero tubes LCD version, which I prefer to their new LED version. I haven't turned this amp on yet, so you're seeing this absolutely live as I see it. So power on both sides, fans going round, that's a bonus. And nothing reading yet because of course the HT is off. Now we'll put the HT on both sides. 460 volts HT, that's okay. They came up very quickly, which is interesting. I suppose the heaters were on during the time I was measuring it, and I'm liking what I'm seeing here. This is looking very nice. We've got 34 milliamps on one side, 33 on the other. That's amazingly well matched. And let's check what the current should be on that. My guess is about 30, well, not far from this actually, 36 milliamps. And to do that I will use a bias calculator from Weber called the Weber bias calculator. tedweber.com, you can find this, and lovely little online tool. Enter in the sort of valve you've got, in our case EL34, oomph. Enter the plate voltage, in our case 460 I'll put, not super critical. Calculate bias, and up comes 38 milliamps on the screen there. We've got 35, 37, I'm not at all bothered by that, that's perfectly alright. However, what I will now do is to put this pair in the middle, just to make sure that the middle, so I don't expect this to change at all. In fact, I'll just turn the HT off quickly. There we go. So I expect to be able to move this to here and this to here, and not to see anything significant in terms of a change. So put the HT back on. So I expect these to settle down to almost identical conditions to how we saw a moment ago, and indeed they are, look. 36, 37 milliamps. So this is fine. Now of course when we put the other pair in, if you remember, one was 5 milliamps hotter than another, so we would have a mismatch on one side compared to the other. But it's not a dramatic one, and it's nothing I would worry about in a guitar amplifier, which is effectively what this is. So this amp, as far as I'm concerned, is good to go, in the sense that we can now put a load on it and measure the power that each side is producing. Obviously I'll put the full complement of tubes in. So let me do that now. I'll get all the tubes in, I'll get it all rigged up for you, and then I'll talk you through it, how I'm going to actually measure the power output of this of both of these stages. And of course I'm looking for 50 watts a side or thereabouts. Okay, let me talk you through this. We've got the power valves back in, preamp valves back in and all secured. I'll show you the equipment that way in a minute, but at the moment I've got a simple jack to jack lead coming out of channel A output, speaker output, and it's going into my load system here. This is just a lot of 10 watt, 100 watt resistors, which allows me to have a dummy load. And then I quite simply use an oscilloscope tacked across the output to measure the peak to peak voltage across the load. Now let me show you what that looks like on the screen. Here's the equipment set up. That's my signal generator, which I've just got set to 1 kilohertz. And here's my scope, which I'm using to measure the peak to peak output sine wave. And what I'm looking for is this sine wave to square off eventually, which will indicate that we've got to peak power, at which point I'm going to measure the peak to peak output, and then I will show you how to convert that to power. Now at the moment I've got this set to 1 volt per division, but I'm using a times 10 probe, so this is actually 10 volts per division. So currently the amp is putting out, well, yeah, nearly 10 volts. So I'm now just going to turn up the gain on the amp and you will see that this will peak at some point, and it's there. I don't want to run it too long at this, and that's 1, 2, 3, 4, 5, 5.5 divisions. I don't want to be thrashing that amp at 50 watts sine wave. So 5.5 divisions. Let's now do a few sums and I'll show you how to convert that to power. Okay, see if this works. We have a sine wave which, if you remember, was 5.5 divisions peak to peak, so that's from there down to here. Each division was 10 volts, so I make that 55 volts peak to peak. Peak to peak is what that's called, peak to peak. To get the power, you use the following method. You take the peak voltage, in which case that will be 27.5 volts. So 27, this is a terrible marker, I don't think I can use this. Oh yeah, 27.5 volts peak, that's from there to there. And you multiply it by 0.707. So I'm just going to get my, don't worry about why, you can look this up if you're interested. At the moment we're plugging in the numbers and we're turning the handle. Just get my calculator up on my phone. So 27.5 times 0.707 is 19.5 volts. Why is that important? Because that's the DC equivalent of a sine wave. As you know, a sine wave spends some time down at 0. So if this is 55 volts peak, it can't be 55 at any significant proportion of the time. It's only 55 at this little bit here. Here it's 27.5. Here it's 35. Here it's 18. So we want to work out what's the equivalent DC of this sine wave. So we work out the power. And the equivalent DC of this sine wave is 19.5 volts. So power is given by V squared over R. DC now. V is the voltage, R is the resistance. Our V is 19.5, so we plug the numbers in here. And remember, our resistance is our load, which is 8 ohms. And this will give us the total power being developed by this amplifier. Let's plug in some numbers and see what that gives us. I can immediately see it's about 400 watts. Sorry, 400 watts, about 50 watts. Because if that was 20 squared is 400, divided by 8 is 50, so we're not far off, look. Anyway, let's do the sums. And it's 19.5 squared, so times 19.5 is 380, divided by R, 47.5 watts. I'm completely happy with that. That is developing 50 watts. Let's see if it has a decent frequency response. In other words, it hasn't got any horrible high-end or low-end reductions which would make the amp sound a little bit thin or something. I'm not quite sure what he's hearing, to be honest with you, but the only two things we can do is check the power and check the frequency response. So let's do the frequency response now. We don't need to do this at full power, so I'm just going to bring the power back and I'm going to set up something here. What have we got? Let's make it, why don't we make it two divisions big on the output, which as it happens it is, so we're going to use that 2 divisions of that as our reference point. And as we sweep through the frequencies, we're looking for it to be pretty much 2 divisions. We don't want to see any dips in amplitude. So currently we're at 1 kilohertz, so let's take it down in frequency to that's 100 hertz. Don't need to go much lower than that. And there you go. See, it's rolled off a little bit. It's down a bit. I'd expect that at 100 hertz. So that's perfectly okay. Now we can come up in frequency. That's our 1 kilohertz again. 2 divisions. Let's wind it up, look, to, we're now at 2 kilohertz, 4 kilohertz, 10 kilohertz. I'd expect to see it start rolling off on the high frequency end in a moment. But look, at 10 kilohertz we've still got a very nice sine wave. and that's getting above most people's hearing threshold, particularly guitarists who can't hear anything above 1 kilohertz. Slight exaggeration there. Right, let's go a bit higher than 10 and see what it does. I'd expect it to start rolling off at about 15 or something. So there's 10 again. Now let's increase the frequency and let's see where it's rolling off. That's 20 kilohertz, look. It's doing extremely well at the moment. That's amazing. And now it is rolling off a little bit. You can see that getting a bit smaller, but that's 40 kilohertz. I'm quite surprised Marshall have let that go. I would have rolled that off at 20 kilohertz. You don't want all these ultra high frequencies stuff going off, and even at 70 kilohertz, look. That's only down, it's not even down 6 dB. There you go, it's down 6 dB at 90 kilohertz. Amazing. So that side of the amp is perfectly okay. All we now need to do is repeat that on the other side of the amplifier. So let's do it. Here we are on the other side of the amplifier. I've got it hooked up in exactly the same fashion. So now we can test the power again. So we know if we get 5.5 divisions at 10 volts per division, we're in business power wise. We don't need to do the calculation again. So let's put this on 1 volt. Where are we? Oops, wrong way. There we go. 1 volt. And now we will wind this up. There it goes. I want to get this back onto 1 kilohertz. It's still on 90 kilohertz. So 1 kilohertz, and we'll bring this back in. There we go. Wind it up, and aha, now, hang on, let's check the gain on the, oh yes, the volume was turned down on the amplifier. Right, so I'm just going to turn that down and see where it squares off. 1, 2, 3, 4, 5. We expect to see it square off any second now, and there it goes. Again, 5.5. 1, 2, 3, 4, 5.5 divisions. So we'll turn that down. I don't want to thrash it. So the power on the second side of the amplifier is perfectly okay. That's giving 50 watts or 49 or whatever it was we saw earlier. Now let's do the same thing again. We've got 1 kilohertz, and we'll turn this up until we get 2 divisions. Here, 1, 2, maybe a touch less on the input. That'll do, 2. And let's check the low frequencies. We're down at 100 hertz now, and we've got 2 divisions just about. It's rolled off a little bit, just like before. That's identical to the previous test. There's our 1 kilohertz again. Now let's go up to 10 kilohertz. Again, 2 divisions, no problem whatsoever. And I think we know what's going to happen here. We'll just wind this up, and it's 20 kilohertz, 30 kilohertz, 40 kilohertz, 50, 60, 70, 80, and it starts to roll off at about 90 kilohertz. So these two sides are very closely matched, and even with that mismatched power valve situation, they're giving 50 watts a side. The mismatched power valve will give you a little bit of crossover distortion. You wouldn't be able to detect it on this equipment, which if it was hi-fi, you would hear as a little bit of distortion on that channel. So as far as I'm concerned, this amp is perfectly okay. It's passed with flying colours. I'm going to have a go at getting rid of some of that residue, but other than that, I don't see anything to worry about in terms of the amplifier. It's working as advertised. Okay, to clean this up, I don't think we need much more than a toothbrush actually. It's very friable, that's the word of the day for you. This material doesn't need any effort to get off. Just comes off extremely easily. I don't think I'm going to go to town on this particularly. I think we'll just get rid of the worst and give it a vacuum. I'm just going to repeat that on the other other tops of these. It's some sort of aluminium crystal growth or something due to the conditions the amp's been stored in. Not doing any harm, just a bit unsightly and kind of flakes everywhere. So we'll just take it all off, I think, and then vacuum it out. As I say, I'm not going to go to town on this, just get the worst of it off. There we go, that's a little bit better. Not perfect, of course. I'm not going to do anything about the rust on these laminations because I learnt something recently. All of my life I had been told or had assumed or had thought or had picked up somewhere that rust on laminations was a very bad thing and somehow it caused eddy currents and degraded the transformer performance or something like that. But a viewer actually put me straight on that and pointed me towards an article, and apparently it has no detrimental effect whatsoever on the transformer. You can clean it off if it makes you happy in terms of it looks a bit nicer, but it doesn't affect the transformer performance. So there you go, another thing that you believe which actually turns out to be wrong, which as far as I'm concerned is pretty much everything I believe. Okay, now we get the lids back on this, and I'll give the customer a quick call to see if he does want a revalve anyway. But other than that, we'll get the lids back on and this is good to go. Okay, so apart from getting it in and out of the case, that was fairly straightforward. I actually put the whole thing back together and I put it back into a spike case, certain that the customer would say no to spending £160 on a revalve, but I just got the last screw in, I was just tightening it up and the phone went. He said, yep, let's go for a full revalve. So I had to take the entire thing apart again and revalve it and do all the tests again, which obviously went quicker the second time through, but it's now got a brand new set of valves in, so that's what the customer wants and it's good to go for a few more years. So I hope you enjoyed that. I look inside an amp that I don't get in very often, but anyway, lovely little amp, and this responded quite nicely to treatment, and I hope you enjoyed seeing how I calculate the power output of an amp, and now you can do that for yourself. So thanks ever so much for watching. I'll catch you as ever on the next video.